Hello and welcome to Exploratory Data Analysis Module 1, a bird's eye view. Here we'll take a quick overview of the topic. My name is Dr. Mark Williamson on behalf of DaCCoTA and the University of North. So what is exploratory data analysis? Well, it's an approach that explores data sets to summarize their main characteristics using summary stats and graphical methods. It's really the first step for a successful statistical analysis of data. So I like to break them up into four main parts. We have viewing data, summary statistics, basic graphs, and basic tests. Let's break those up a little more and explore their landscape. With viewing data, there's a number of things we can do. We usually look at our data through an Excel spreadsheet or something similar. We can look at an observation number, variable number, as well as type, category, and structure of those variables. We can use summary statistics to get one or a couple number summary, like central tendency through mean, median, mode, spread through range, variance, and standard deviation, as well as looking at problematic things like outliers or missing data. We can use basic graphs to visualize relationships. We can use histograms, QQ plots, bar, box, and scatter plots. Finally, we can also use basic tests to do things like check assumptions or run simple models like t-test, correlation, ANOVA, or even the more general linear model. Now let's go a little more into the structure and uses of each part. We can view data. Here I just have a mock data set. We can look at observation number, which is really the number of rows. That gives us something like the number of samples. Here we have 10 students. We can get the variable number by looking at the number of columns, 6 in this case. In our variables, we can look at their big categories. The first one would be like nuisance or bookkeeping. You're not going to use this in the analysis. So number is an example of that. It really tells us we have 10 students. Then there's the dependent variable. This is usually the variable or variables you care about, you want to analyze. So here I have body temperature. And then independent variables, like these four, are ones that we expect have a relationship or can help predict body temperature. Now within the variable categories, there's types. There's numerical, which can be discrete, which means like age here, they have integer values that can only be a discrete number. Whereas continuous numerical, like weight here, can be any range within a continuum and often show decimals like here, as well as things like body temperature. Then there's categories, which are not numbers, like major and grade. They can be nominal, like major. There's really no way you can order these from high to low, worst to best, or anything. But ordinal ones like grade, we can see they can be ordered: freshman, sophomore, junior, and senior. And then we can look at more complicated structure, like whether the data is long or wide, paired, or repeated measures, but those are a little more advanced. Now let's look at the structure and issues of summary statistics. The first three here, mean, median, mode, are all a way of detecting central tendency. The mean, also known as the average, is really the sum of all numbers divided by the number of values. That's very nice, but it can be thrown off by untidy data. So a median, known as the middle value, is really less influenced by things like outliers than the mean is. And the mode, which is sort of the lowest resolution, can give the most common values among observations. It's actually pretty good for like categorical data. Range, variance, and standard deviation all kind of show the spread. Range is just like the difference between the highest and lowest value, the min and the max among observations. Variance is how much the values are spread out, and it's the average of all numbers, how they differ from the mean, the central value. Standard deviation is similar to variance. It's actually the square root of the variance. Outliers are very high or very low values. They can be true, like measurements, or they can be some sort of error, like you forgot to add a decimal in the number 1, so it became 10, or something like that. And missing data, it's data that should be there, but it's not. It might be an error, like you forgot to enter the number in, or you simply couldn't measure it for that observation. Now here are some graphs. They can show visual relationships. Histograms and QQ plots are good for distribution and actually checking a thing called normality. Histograms are nice because their frequency by, say, cancer rate here. You can see like the most frequent ones are around 50, though it spreads out quite a bit here. And you see it's not very symmetric. That tells us something about normality. QQ plots, if the data is tidy or symmetrical or normally distributed, whatever you want to call it, most of these dots should really kind of line up along this line here, but you can see they're not. Box plots, bar graphs, one shows median, as well as a lot of other information, other just shows means. You can see through these 4 different cancer types that breast and prostate are spread out, are higher than the other 2 and also more spread out. The thick bar is the median. These are quartiles and these are the ends. And then these are the outliers. And bar plots just have means. You usually have things like confidence intervals or error bars when you actually do analyses, but these are just kind of simple plots. Finally, scatter plot shows a relationship between numerical variables. So this is population and lung cancer rate. If a line can be reliably drawn from the bottom to the top here, that's a positive relationship. From top to bottom, that would be a negative. If it's pretty much more or less flat, that's really no relationship. It's hard to tell from here. It's probably more flat. Finally, there's basic tests. First of all, you can do a very important step called checking your assumptions. A lot of statistical analyses require certain assumptions, like is the data normally distributed, and you can use like a histogram or a QQ plot for that. You also ask how large the variance or equal observations across groups, other important assumptions. Those can be done with summary statistics. Then there's a simple t-test, which asks if there's a difference between one group and a set value, or like a difference between 2 groups. And you'll often show the results of this by a box or a bar plot. Correlations, is there a relationship between 2 numerical variables? And that would be a scatter plot result. ANOVA is sort of like the t-test, only it's a little more advanced. You can actually ask if there's a difference between 3 or more groups. And again, a box or bar plot shows the results. And the more general test we would call a linear model, which is really saying, can the dependent variable be predicted from one or more independent variables? It's a more general case, a lot of these tests. Okay, let's look at some real-world examples. So here's a couple of histograms. We see that this one's pretty symmetrical, but it has this kind of tail on its right side for commute time. This one we see we can actually have different groups. So we have male and female by height. We actually see that taken individually by gender, the heights are pretty symmetrical, and we see that males are on average taller than females. Now here's a QQ plot. The first one here is not normally distributed. It's not even close to the line, where this one is much closer, much better. Here are a couple box plots of gender and time, and this is a 3-way one, which different lengths of irises. Here is a bar plot, and we can see we're actually looking at 2 different groups. Class, this is for passengers on the Titanic, as well as survival. We can see that most first-class passengers survived, where most crew died, though there were a lot more crew to begin with. And here's another way of showing it. This was stacked. This is a clustered 2-group plot for male and female side by side across day. Here's a scatter plot. We see as driver age increases, their viewing decreases. So this is a negative correlation, or it looks to be one. And this is another one with as age goes up, so does size, and that seems to be positive. And then here are a couple tables that are good for showing summary statistics. So we got different classes, and these are different variables for cars. All right, let's do a quick assessment here. I would ask you to pause this video, write these down yourself, and see how you did. Okay, great. I hope you're back from pausing. Let's go through these. First one, what are the 4 basic parts? Well, we walk through them: view data, summary statistics, simple graphs, and simple tests. graph you'd use between two numerical? Well, that's a scatter plot. What part helps determine variable number and so forth? Well, that'd be viewing the data. Summary statistics known as the average, it's the mean. If you're on ANOVA, how would you plot it? Well, a bar or box plot. And then this is a histogram. Okay, in summary, exploratory data analysis is the first step in a good analysis. You can view data, determine type and structure. Summary statistics summarize it numerically. Graphs help visualize. And simple tests provide a further guide for analysis. So thank you for joining us on this bird's eye view. Tune in next time for a stroll through the core components of exploratory data analysis in Module 2, Leaves and Trees. Thank you.